travel far distances from one ward to another. That is, the wards are closely placed in a cluster. It's not key. I'm in ward one and I'm traveling diagonally opposite to ward 30 or ward 40 in a cluster. The mean distance minimization means the wards in a cluster should be closely spaced. So that is what we mean here. And then we have given a provision. So since like that, there are different parameters of the objective function. The beauty of our algorithm is that we can actually play around with this. We can change the relative importance of each of these. So for example, what is variance of distance? Variance of distance means that if I'm a PHC worker who is assigned a particular cluster, so while traveling the inter PHC distance, the variability in inter PHC distance should not be very high, which means that if I am a PHC worker 1 assigned cluster 1, and if you are a PHC worker 2 assigned cluster 2, then the variability in inter PHC distance which I am traveling should be more or less equal to the variability in inter PHC distance which you are traveling. This is basically taking into account the problem of social impact. If I am traveling very large distance, I might feel very much overburdened, or I might feel tired, and this might reduce my efficiency. So I need to minimize the variance of the distance travel. That is, I need to minimize the variance of workload. Similarly, there is variance of population. Population means the population served. So this means that if I'm at a particular cluster, if I'm serving to, let's say, 100 population, then people from different clusters should be serving to more or less than 100. The variance of population from each ward should be more or less the same. Okay, so this is one parameter as well. So we can actually play around with the relative dependency. So for my case, this is very much important, so I'll keep this to be 50%, because we need the clusters to be close by in order to enhance the reach, and in order to save a lot of time and money. In this case might not be very important, because each community health worker might have a extensive travel option in terms of three-wheelers, trains, buses, etc. So even if he has to travel larger distance, he might not find it really very tiring or very significant. So I'll keep the weight to just 10. And but variance of population is very important. Population is directly, in this case, population means the amount of people I'm catering to, which is directly proportional to the workload. So this will be very important. So I'm keeping the count to 40, and that's all. So for this problem, we are using these variables. However, if you have any other problem, you can always change the dependency of variables, and you can also always change the name and data of the variables, and the relative importance and the input variables. You can do whatever you want. Okay, let's click on evaluate and see what result we get. So while it gets evaluated, I'll just give a brief on what is module 2. So module 2 here is dynamic simulation, which means that, so in module 1 what we assumed was the demand, or the population of each ward remains constant with time, which is more or less the case in this scenario. But what if the demand actually changes? What if the population actually changes with time? Or what if, let's take a different scenario wherein we are trying to find out the optimum location of ambulances. So in that case, the demand will actually change, because in that case the demand is what? Demand is just the prevalence of accident. So if a ward or if a region is near a highway, the prevalence of accidents may be high at night, but may not be high yet in the morning. So the demand actually keeps on changing. So we need to dynamically reallocate the ambulance in order to enhance maximum reach, as well as the social problem, if that is important. But I don't think in case of ambulance the social problem is of much importance. So we can appropriately modify these functions. So we just need to import data at different time intervals, and we just need to keep evaluate. So we will get a dynamic model, a dynamic reallocation model of the data. This similar can be applied for inside hospital scenarios as well. For example, the demand at various stations in hospitals may change from day to day. For example, Monday the hospital may be overburdened, or Tuesday the hospital may be less burdened. So in that case, we need a dynamic reallocation of resources inside the hospital. Okay. So we see that we have reached the completion for this test problem. Um, I'll click on the graph. So what I'll do is I'll just click here and drag it and make the graph. So we can see each of these circles are different PHCs, and these are color coded. The color coding means the workers which are allocated PHCs or ward or whatever, and so this is what we get. This is the optimized geospatial resource allocation, which takes into account the problem of social cause, as well as distance minimization and reach enhancement. We can so this result is not in a usable format, so we can also click on export result. In that case, we'll get a CSV. So basically, this software, we are just seeing a test problem, which is quite simple. But we can take n number of variables, n number of constraints, and n number of objective function parameters, and we can also play around with the relative importance of those parameters. That is the beauty of this software. This software is basically extremely customizable. This software actually gives power to you. It uses a very powerful genetic algorithm, which is a machine learning algorithm. And all you need to do is you need to specify what all constraints you are taking, what all parameters you want, what is the relative importance of each parameter according to you, the input data, and we're through. Uh, that's all. There are many test cases which can be done. So this software can literally optimize anything and can be used for any problem. So, and the best part is this is coded in R, which is open source, and can be very easily incorporated with your existing infrastructure. Thank you very much.